My background had been working in medical informatics and developing what we would now call ontology languages and reasoning systems, although actually, to be honest, in the medical informatics area we weren't necessarily calling them ontologies back then, we do now. And I went to a meeting of a European network, met people like Frank van Harmelen, Dieter Fensel, who were also interested in this, got interested in the beginnings of this area, and I managed to convince them that this description logics area, which I'd been working in, which was a sort of logic whose rationale is to formalize what we now call ontology languages, that would be a good starting point. It had more expressive power and a very clear formal semantics, was just first order logic basically, just a fragment of first order logic. And we went from there. And between us we developed a language called OWL, which was based on a description logic, which was already around at the time. We met people in the US like Jim Hendler and the DAML program, people working on the DAML program. We all decided that, hey, you know, we're more or less trying to do the same thing, why don't we pool our resources, which we did. Came up with DAML plus OWL, wasn't really much different from the OWL thing, and then the idea was to go for, you know, to try to develop this into a standard so more people would really be able to use it. And this was where OWL originally came in. And then, you know, the OWL working group started and we went through the process. What we thought would be the easy process of standardizing DAML plus OWL as a web ontology language. So then, of course, a whole new bunch of people joined the party, which were the sort of web people. And of course, they had a whole load of concerns of their own, things that were important to them, which were things like integration, compatibility with RDF, and generally with web infrastructure and existing standards. So actually the process then of changing DAML plus OWL, evolving DAML plus OWL into OWL, took longer than we thought, involved a bigger change than we thought, and I think it took a couple of years in the end. And much more than that off my life, 10 years off my life, I think. But I mean, it was pretty interesting, and I learned a lot there as well. And the language evolved, not a great deal, but it was mainly the syntax and the relationship with RDF that changed. The underlying logic didn't change very much, and of course the semantics didn't change because that just flows from the logic. The huge impact of OWL was just the fact that there'd been these kind of KR languages around for donkey's years, as you know, but there'd been, you know, every university research group had typically created their own variant, their own little flavour, all somewhat incompatible, and it had been conjectured that had interfered with the take-up. But of course, you could never really tell whether or not there would be significant take-up if you had a standard language that everybody was using, until OWL came along, when suddenly we had that thing. We had a standard KR language that was kind of supported by lots of different groups building infrastructure, and suddenly applications people started to feel more comfortable about using that. It had always been an issue, you know, if you were using the system from the University of X and then that research group just suddenly got bored with that and went off and did something else, so you were left with no support, whatever. Now with OWL, you could use a standard language, there were tons of people supporting it, ever-growing sort of array of infrastructure to support, building, deploying, maintaining ontologies. And that meant that people then really started using it. I mean, People in industry to some extent, but initially probably more, other academic disciplines, scientists, researchers.
Did whole industries sort of kind of form that you wouldn't have anticipated based on once you got the plumbing kind of right?
But I think the thing that struck me initially about OWL was the fact that once we just agreed we were all going to use 15 mil pipes, then, we could have a huge industry of people building all kinds of cool plumbing stuff that could all fit together and do amazing stuff that we would never have anticipated in advance. And that was the thing about OWL. It's not that OWL was the perfect language. It's not that 15 mil is the right size for a pipe. It's just at some point you have to say, okay, I would have gone for 18 mil, you would have gone for 13 mil. We'll compromise here. We'll fix on 15 mil. We'll get on with it. And then we'll see what we can build with that. And this is what happened with OWL. There was huge arguments. In the end, we managed to reach a compromise that everybody could sign up to. Some with more grumbling than others, but everybody signed up to it. And then, people started building stuff. And now the thing that amazes me today, with both OWL and RDF actually, is that you just bump into people all the time who are just building applications using OWL and RDF tools and infrastructure that you never even knew about before, because that stuff just works now. They just download it off the web, they build it into applications, they're pretty happy. It may not be, if you look at what they did, you may say, well, if I were doing that, I'm not even sure I would have really used RDF and OWL. But they downloaded the tools, worked really nicely, they were super happy with it, and the toilet flushed in the end. Job done. And I think one of the things as a community we haven't been very good about is embracing that as a great success and saying, yeah, we've done a really good job here, we've built stuff that people are using and it works. It really kind of works off the shelf these days. The tools and stuff are pretty robust and we should be proud of that. It's an achievement of the community.